go. Alright, so then now I have the negative 5 over 10, which becomes negative 1/2. And then who can tell me what's GT when it's straight up and down? Slope.
Undefined.
Undefined. Alright, so who can tell me with OA, how are we going to find the distance of OA? Pythagorean theorem is going to be the easiest thing. So when I do my a squared plus b squared equals c squared, and I just take the positive numbers. The negative doesn't matter for Pythagorean theorem. So that gives me, I can type it in the calculator. I can do it this way. So 125 equals c squared. Take the square root. Is that a whole number when you take the square root of it? Who has their calculator out? No, so if it's not a whole number, we square it again. And go ahead and draw our factor tree. So we do 5 times 25, 5 and 5. So then doubles go outside, the single 5 left over stays inside, so the answer is 5 root 5. So then the really good news is, I just did all the math for a triangle with sides of 10 and 5. Is it going to be the same for T and A? Yeah, even though the slope was different, it's the same 5 and 10. So that's 5 root 5 again. And then GT we can just count. What does that come out to when you count it? 5. Okay. So now we're going to write our statements, and then we'll check and make sure we've done what's required for the proof. So looking at this, are any of the slopes congruent?
No.
No, so I'm not going to label anything parallel. So instead I'm going to label which sides are the same. And so I'm going to write out GO equals which side? Sorry. There we go. So GO equals GT. And then OA equals what? AT. Okay? And so kite is one of those things. It says step 1, step 2. We have to do both of these statements to prove it a kite. Okay, so kites always have two proofs. One is that we have the two pairs of consecutive congruent sides. So that's what we just did. We say these two sides that are beside each other equal, these two sides that are beside each other equal. And then next one, we have to find the slopes of the two diagonals, and they must be perpendicular. Okay, so this is the only shape that you have to do something with diagonals. The other ones you can prove from the side lengths. This one you have to do diagonals. And so diagonals are going to be GA and TO. So we just count our rise over run. Going from G to A, what is my rise from G down to here? 10. So we already counted 5 here and 5 here. So it's just negative 10 because I'm going down, over 10 because I'm going forward. OT is 5 over 5, right? Positive or negative for TO? So it depends. If we count from O to T, it'd be negative 5 over negative 5, which would cancel out. If we go from T to O, it's positive, positive. Either way, that's a positive line. And so I have my diagonal slopes now. And so those simplify to negative 1 and 1. Are those opposite reciprocals? Yes. So I'm just counting out to get from G to A. It's just my rise over run. So G I counted down 10, and over 10. Today, quick check is just the assignment again, so we're going to do it and grade it, just like last class. So then I just write GA is perpendicular to TO, and I have to prove it by writing out what numbers those are there. So we have 1 and -1. And here I forgot to write it, but this should have been 5 and 5√5. So when we're doing proofs, you always want to back it up with, hey, what number makes you know those are parallel or perpendicular or congruent? All right, so when you have all that, flip to the next page. It's our last page of notes for this packet. Okay, so our last shape we're proving is trapezoid. So trapezoids have one pair of sides are parallel, and one pair of sides is not parallel. Okay, so we're going to write the statement for both sides, but we'll either say yes parallel or not parallel. And then when it's a trapezoid, you always have to prove, is it isosceles or not? So we'll always have two statements for trapezoids, just depending on whether we have to say, is it isosceles or not. So would you write at the top of your page two statements for trapezoids? So this one already worked out. It already worked out slope and distance, so we're not going to worry about the graph right now. We're just going to write statements from what they gave us. So if I write KA, I have a volunteer who will tell me, is KA parallel to another line?
Yes.
Yes. Which one? TE. So I'm going to write it's parallel to TE, and they have the slope of 2/3. Okay, now I'm going to take the other two sides and say, hey, they are not parallel. So not parallel, I just do the parallel symbol and cross it out. And that was my -4/3 and undefined. So anytime as you're identifying figures, if you have one parallel and one not parallel, it will be a trapezoid.
What's the N for? It's
Undefined. All right, now we're going to go to, we have to say, is it isosceles or is it scaling? So method 1 is with diagonals using distance. Method 2 is saying non-parallel sides are equal. Because we have the chart that already gave us distance, we're going to just do a statement. Which are our non-parallel sides? The KA and TE, or AT and EK? Yeah, so I'm going to, my next statement for trapezoids will always be with those same sides. So AT and EK, do they equal each other or not?
No.
No, because it's 5 and 6. So again, I do the equal sign, cross it out. That's the not equal sign. And so that's because it's 5 and 6. They don't equal. Is it easy or confusing? Or in between?
I feel like I'm just writing symbols down.
Okay, so take a minute and look at it. Make sure you understand what those symbols and letters mean. And if you don't, you raise your hand or give me a thumbs down or something so I know to explain it again. So do you understand what these symbols mean?
I do. Equal and congruent. No parallel. Parallel.
Yeah, so make sure you're matching up the words with the symbols and then the numbers with the words. All right, so then we would write down scaling trapezoid. Or some people just tell me it's a trapezoid and not isosceles.
Wait, like, I think forgetting what the difference is isosceles, trapezoid is.
Yeah. So I'm going to give people a minute to write that out, and then I'll show you the pictures again. Or I can graph this. Okay, so a trapezoid, a scalene trapezoid, is when we have those parallel lines, but these two sides don't equal each other. An isosceles trapezoid is when you have those parallel lines and then the sides equal each other. So see how it's a really uniform figure there? You could cut it in half and it would be, so opposite, one pair of sides is parallel, the other pair of sides equals each other in length. And so it makes a figure like you could fold it in half vertically and it's symmetrical. Mm-hmm. Whereas just scalene trapezoids are not symmetrical. Alright, you guys, one last shape, and we are done with notes for this packet. If I find it again. Okay, so this time I'm going to start. MI is parallel to what?
Okay.
What should my next statement be?
IL and KN don't equal each other, or are not parallel?
Yeah, so IL is not parallel to KM because they're undefined in 0. And what should my third statement be? So is my next statement going to have the MI and LK? Or will it have
IL
I?
and KM.
Yeah, so I always take my non-parallel sides. So IL and KM. Equal or not equal? This time they equal. They're both 3. And so it is isosceles trapezoid.
So we don't have to graph them, or do we have to?
You don't have to. It sometimes helps if you like the visual to graph it and just see.
So we can just write it out like that.
Yeah, you can just write it out like that. There will be one section of the test, I think like 2 problems where you're getting graded for did you graph it correctly. But most of it is just can you write these statements. Yes, you can. Alright, so we are done with our notes. So what needs to happen now, I'm going to stop the